Hello there, and welcome back to Sleepy Science Stories. I'm glad you're here, resting, listening, maybe already lying down beneath a quiet ceiling or a dim sky. The night outside moves slowly, the air perhaps still, perhaps breathing through an open window. This is your time to unwind, to let the noise of the day fade into something softer. Tonight we travel gently outward, not in a ship, but in thought, toward a companion of our own galaxy, the great Andromeda. It waits there in the dark, immense, yet almost invisible, a faint blur suspended beyond imagination. If you step outside on a moonless night, far from the city's glow, you might see it yourself. A delicate patch of silver light, so small to the naked eye, it could almost be mistaken for a smudge on glass. And yet, that blur is another galaxy, a vast congregation of suns, planets, dust, and time, the nearest spiral neighbor to our Milky Way. Andromeda is one of the few galaxies we can see without a telescope. It's been known since ancient times, watched by eyes long before telescopes existed, before the idea of galaxies was even born. To those early observers, it was a mystery, a soft flame in the dark, something neither star nor cloud. Tonight we'll drift into its story. We'll move through its ancient light, its staggering scale, and its quiet motion through space. We'll listen to the numbers not as noise, but as rhythm, the way the universe breathes in distances and ages. So take a slow breath in. Let it out gently. Let your thoughts loosen their grip. There is nowhere else you need to be but here in the space between wonder and rest. Now look up in your mind to that faint blur of light millions of years in transit, and ask softly, how big is the Andromeda Galaxy really? And where in the world are you listening from tonight? Are you under city skies or somewhere quiet, where the stars still shimmer? If you enjoy these calm explorations, a soft tap on the like or subscribe button helps other sleepy minds find their way here too, one quiet soul at a time. You don't have to move. You don't even have to stay awake. Just listen and drift. The universe will wait. Still lying quietly beneath that inner sky, imagine the world dark and open horizon, soft stars scattered like seeds across the air. Somewhere near the constellation of Andromeda, a figure drawn from ancient myth there hangs a blur of light so faint that most eyes pass over it. Yet, once you notice it, it stays. A soft almond-shaped glow hovering between stars. That is the Andromeda Galaxy, also known as Messier 31, our closest great galactic neighbor. Its light began a long journey 2.5 million years ago. That means what you see tonight, even through a telescope, is an echo from a time when Earth was a very different world. When glaciers shifted across northern lands, when early human ancestors shaped the first tools of stone, the photons now touching your eyes left Andromeda before our species had a name. They have crossed intergalactic space, a distance of 25 quintillion kilometers, and arrived only now, gliding silently through your window, brushing softly across the night air. Each of those photons began inside a star, perhaps a blue giant blazing at 20,000 degrees, perhaps a red dwarf with a quiet, steady hum. They left their origins, drifted through Andromeda's spiral arms, escaped the galaxy's haze of dust, and continued outward through the thin ocean between galaxies, a space so empty that a single atom might drift for kilometers before meeting another. They moved past small companion galaxies, through the gravity wells of invisible dark matter, through nothing and not nothing, until they reached this small planet and the back of your eye. You are seeing the past as light. You are meeting ancient fire in the present. And in that simple act of seeing, time folds. When you think about it this way, Andromeda is not just an object in the sky. It is a living archive of the universe's memory, the sum of uncounted lives of stars of light traveling endlessly forward, of galaxies drifting closer together in cosmic rhythm. And yet, to our senses, it is fragile, barely there. Its light lies at the edge of visibility, easy to overlook amid brighter stars. But that is part of its quiet beauty. It reminds us that vastness does not need brilliance to be seen. It waits patiently to be noticed. If you were standing under an exceptionally dark sky, perhaps high in the mountains or far out on a desert plain, Andromeda would appear as a long oval smear, slightly brighter at its core, fading gently toward the edges. Most of its light comes from that central bulge, a dense sphere of older yellow stars packed so tightly that from afar they blend into a single golden mist. But the true body of the galaxy stretches far beyond that glow, about 220,000 light-years from edge to edge. That's twice the span of our Milky Way. Imagine that for a moment. A beam of light leaving one side of Andromeda would take more than 200 millennia to reach the other. Whole civilizations could rise and fall in that time. Even on cosmic scales, it is enormous. A rotating system of about 1 trillion stars, each a sun with its own possible worlds, its own warmth, its own story of fusion and flame. Yet from here on Earth it seems small. To our eyes it fits comfortably in the space between two fingers held at arm's length. But if human sight could sense the fainter parts of its halo, the extended disk of scattered stars and dark matter, Andromeda would span nearly 6 times the apparent width of the Moon. You could hold out your hand and cover a galaxy with your palm. What we see is only its brightest center, the narrow core where gravity has drawn stars close together. Its spiral arms are vast but dim, their light stretched thin across distance. Much of that structure is invisible to us without instruments. Astronomers map it using long exposures, allowing faint light to accumulate like dew, revealing the delicate whorls of stars and dust that spiral outward. Within those arms are regions of creation, pink clouds of hydrogen gas, where new stars ignite, where planetary systems may be forming, even now unseen. Between those arms, dark lanes thread like shadows across the galaxy's face. These are rivers of interstellar dust, tiny grains of carbon, and silicate the raw ingredients of future worlds. They absorb and scatter starlight hiding parts of the galaxy behind a gauze of darkness. When you look at Andromeda, you're not seeing through emptiness. You're looking into a living structure, dense, rotating, changing over billions of years. Astronomers call it a spiral galaxy, though even that word feels too simple. Its spiral arms are not fixed like the blades of a pinwheel. They are waves, patterns of density moving through a sea of stars. Imagine a traffic jam on a highway where cars move in and out, but the jam itself stays. The arms of Andromeda work like that. Stars drift through them slow and bright, and within those zones, new stars are born. Then they move outward, aging, cooling, spreading light. And in the middle of it all, at the very heart of Andromeda, lies a supermassive black hole about 100 million times the mass of our Sun. Around it, stars orbit at breathtaking speeds, completing their revolutions in mere centuries. The core glows intensely in infrared and X-ray light, a signal from matter, spiraling inward, heating to millions of degrees, before it disappears beyond the event horizon. It is the quiet engine of the galaxy, invisible, yet shaping everything around it. To look at Andromeda, even faintly, is to witness scale beyond comprehension. It stretches across mind as much as across space. And yet, it has always been part of human awareness, long before the telescope, before science separated myth from measurement. Andromeda was a figure in the constellations, the princess chained to a rock in Greek legend, waiting to be saved from the sea monster Cetus. Her story stretched across the northern sky, and the faint cloud of light within her constellation carried her name. Ancient Persian and Arabic astronomers noted it too, describing it as a small cloud in their star catalogs. No one knew what it was. For centuries it remained a mystery, perhaps a distant nebula, perhaps a gathering of faint stars. When telescopes first turned toward it, observers saw swirls and filaments like smoke in water. They called such objects spiral nebulae. It was only in the early 20th century that Edwin Hubble, studying Andromeda through the 100-inch Hooker telescope at Mount Wilson, identified individual variable stars within it, Cepheid variables whose brightness rhythm reveals their distance. By measuring them, Hubble discovered that Andromeda lay far beyond the boundaries of the Milky Way, so far that it could not possibly be part of our own galaxy. That single realization changed everything. The universe expanded in human imagination overnight. No longer was the Milky Way the entirety of creation. It was one island of stars among countless others, and Andromeda became the first clear evidence of that greater sea. Now we know it as the largest member of the local group, a gathering of roughly 50 galaxies bound together by gravity. Among them, the Milky Way and Andromeda dominate like twin spirals drifting toward one another through the void. Between them lies 2.5 million light-years of almost empty space, a gulf that gravity is slowly closing. Andromeda moves toward us at about 110 kilometers per second. Over eons, that motion will bring the two galaxies together. In roughly 4 billion years, their halos will meet, their stars will begin to mingle, and the galaxies will merge into a single larger structure, a new elliptical supergalaxy sometimes called Milkomeda. The night sky, then, will change completely. But tonight, it is still peaceful, two galaxies drifting closer, not in haste, but in timeless dance. When astronomers compare the two, they find differences and echoes. The Milky Way is a barred spiral, its core shaped by a central band of stars. Andromeda lacks that bar, though its spiral arms are more pronounced. The Milky Way spans about 100,000 light-years, while Andromeda's disk doubles that. Our galaxy holds perhaps 400 billion stars. Andromeda may hold 1 trillion. Its central black hole outweighs ours by a factor of 25. And yet the Milky Way forms new stars at a higher rate, younger, more restless, still glowing with creation, while Andromeda ages in quiet grace, its star-forming regions less active. It helps to imagine them as companions rather than rivals. Two cosmic dancers circling one another slowly, their orbits dictated by mutual gravity. Their meeting will not be violent to stars themselves. The distances between suns are so vast that few will collide. Instead, their shapes will flow together like ink in water, forming bridges and streams of stars' tidal tails arcing across hundreds of thousands of light years. Over time, the chaos will settle into a single rounded form, galaxies reborn as one. But that is far ahead, far beyond the lifetime of our sun. For now, Andromeda remains our distant neighbor, calm, immense, and visible in every clear autumn sky. And still a question lingers. How do we know these things, the distances, the speeds, the masses of objects we can never touch? The answer lies in light itself. Scientists measure Andromeda's distance using the rhythmic brightness of Cepheid variable stars that expand and contract with clock-like precision. The time between their pulses tells us their true luminosity, and by comparing that to how bright they appear, we can calculate how far away they are. This was Hubble's great insight. Later, other methods refined it. Type Ia supernovae, used as standard candles, offered distance measures even farther out. Spectroscopy reveals another truth. Andromeda's light is slightly blue-shifted. Most galaxies in the universe are red-shifted, their light stretched toward longer wavelengths as they move away. But Andromeda's light shifts toward blue, showing it is moving toward us, not away. The shift corresponds to that speed of about 110 kilometers per second fast, but gentle on cosmic scales, a slow spiral toward eventual union. Other techniques probe its hidden mass. Rotation curves graphs of how fast stars orbit at various distances from the center show that the outer regions of Andromeda move faster than visible matter alone can explain. This tells us that most of its mass is invisible. Astronomers call it dark matter, a halo of unseen substance surrounding the galaxy, outweighing its stars by several times. Though we can't see it, dark matter's gravity holds the galaxy together, shaping the motion of its stars and the bending of light around it. When radio telescopes map Andromeda in hydrogen emissions, they reveal gas extending far beyond the visible disk. A soft, whispering envelope of neutral hydrogen, reaching hundreds of thousands of light years into space. Within that gas float smaller galaxies, companions long captured by Andromeda's gravity. Two of them, M32 and M110, are visible even in small telescopes, pale ellipses of stars orbiting close to their giant host. They are remnants of galaxies slowly being consumed, their stars stretched into tidal streams, wrapping around Andromeda's halo. In this way, Andromeda grows. Galaxies feed on one another, not violently, but through long, quiet absorption. If you could look at it through different eyes, infrared, ultraviolet, X-ray, you would see a structure alive with contrast. The bright yellow center, full of ancient suns, glows warm in infrared. The spiral arms shine blue-rich with massive young stars, only a few million years old. Between them, knots of pink mark nebulae, where hydrogen clouds collapse and ignite new light. Dust lanes curl through the arms like soft shadows absorbing starlight, shaping the galaxy's pattern. Every color tells a different part of the story: formation, aging, renewal. and still from Earth it appears small. A wisp of silver no brighter than a candle seen from a continent away. The mind struggles to bridge that contrast between what it is and what it looks like. Andromeda's apparent stillness hides furious motion stars racing through orbits at hundreds of kilometers per second, clusters, swirling gas clouds, collapsing supernovae, flashing and fading. Yet, from our distance, all that energy blends into calm light, a reminder that scale itself is a kind of silence. Some nights it helps to think of that light as music slowed beyond hearing. Each star a note, each orbit a rhythm. The galaxy as a chord that takes millions of years to resolve. And then, returning to yourself lying quietly, now you realize that this immense system, 2.5 million light-years away, filled with 1 trillion suns, shares the same cosmic fabric as you. The same atoms that compose Andromeda's stars exist here within your body. The calcium in your bones, the iron in your blood, the carbon that builds your cells, all forged in ancient stars that once burned and died, scattering their elements across space. You are part of that same story. To see Andromeda is to recognize that connection not as metaphor, but as fact. We are stardust observing starlight. And somewhere in that galaxy, perhaps on a small planet circling a quiet sun, another being might be looking this way, seeing a faint blur in their own sky and wondering what it is. From their view, the Milky Way would be that blur, our entire home condensed to a single pale smudge. Two perspectives opposite and equal, gazing through space and time toward one another. The universe in its calm enormity allows such symmetry. Now let the thought settle. Let the distance unfold in your mind, vast yet peaceful. Andromeda drifts there, still silent across the darkness, sending ancient light to meet the present moment. Even as you breathe now, galaxies turn, stars form and fade, time stretches quietly onward. You are still drifting there in thought, somewhere between sleep and space. Andromeda lingers above your inner horizon, that faint soft oval suspended in the dark. In the stillness, it feels both near and infinite, like a single breath held across time. A moment ago, we traced the path of its ancient light, 2.5 million years in flight, arriving just now to meet your gaze. That light tells a simple truth. Andromeda is immense beyond imagining. Yet in that immensity, there is structure, harmony, and a kind of slow serenity. When we say Andromeda spans 220,000 light-years, the number is too large for the mind to grasp all at once. So, let's unfold it gently. 1 light-year is the distance light travels in a single year, about 9.46 trillion kilometers. Multiply that by 220,000, and the result becomes a number so large that it feels almost abstract, more than 2 million trillion kilometers from one end of the galaxy to the other. And yet, that is only its visible form, the part where light still shines. Surrounding the bright disk lies a vast ghost-like halo made of dark matter and ancient stars reaching far beyond the luminous spiral arms. It stretches outward for perhaps 1 million light-years, a sphere of invisible gravity wrapping the galaxy in silence. Imagine standing somewhere inside that vastness, if such a place could exist, looking outward across a panorama of suns. You would see stars scattered in every direction, a river of light curving into the distance. The nearest stars would gleam bright as our own sun. Farther ones would shimmer faintly, filling the sky until it looked like an unbroken sea of silver dust. The concept of night would vanish. There would be no darkness left between the stars. Andromeda contains roughly 1 trillion suns. That means if you could count one star every second without stopping to sleep, it would take more than 30,000 years to finish counting them all. Many of those stars are older than the Sun. Some are just forming. Many harbor planets' worlds we will never see circling their stars like quiet thoughts. If you could look closer, you would find star clusters within it, each holding thousands of suns bound by gravity. Some of them are ancient globular clusters, tight spheres of aging red stars orbiting the galaxy's core. Others are open clusters, looser gatherings of young blue stars just beginning their cosmic lives. These are the nurseries and the fossils of Andromeda's evolution, the galaxy's memory written in light. Now picture its spiral arms turning. The galaxy rotates through so slowly that from our perspective it seems still. A single revolution takes about 240 million years, roughly the time it takes our Sun to circle the center of the Milky Way once. So, in one galactic rotation, entire epochs pass on Earth. Continents drift. Species rise and vanish. Ice ages come and go. Andromeda's turning is beyond hurry, a motion so patient it could be mistaken for stillness. That is what makes its scale so difficult to hold, not only its size in space, but its size in time. A galaxy is a long story told in slow syllables, star by star, orbit by orbit, age by age. If we could watch its formation in time-lapse, the picture would be one of continual transformation. Long ago, small galaxies collided and merged, each one adding its mass and momentum. The spiral arms took shape from these gravitational dances, forming a graceful pattern that now seems eternal, but is only temporary, a frozen wave in the ocean of time. The stars within those arms orbit at different speeds, bound together yet always shifting like the turning of a great clock whose gears are made of suns. Andromeda's core is dense and golden. Billions of older stars crowd together there, their light blending into a single amber glow. Around that core, dust lanes swirl filaments of carbon and silicate grains, the ashes of former stars floating through the inner regions like ink suspended in air. From these materials, new generations of stars may one day form, each carrying the remnants of the past into the future. If our eyes could see beyond visible light, Andromeda would look even larger. In ultraviolet, its arms burn bright with hot young stars. In infrared, its older stars and dusty lanes reveal a web of warmth. Radio telescopes show vast clouds of cold hydrogen stretching outward, invisible to sight, but real as any star. X-ray instruments reveal clusters of binary stars and the faint glow of the central black hole feeding slowly in the dark. Each wavelength shows another layer, like lifting veils from an ancient painting, one by one. What makes this so wondrous is that all this structure, the luminous disk, the extended halo, the curling arms, is held together by gravity, that quiet sculptor of the cosmos. Gravity doesn't hurry. It doesn't announce itself. It simply draws matter into harmony-shaping stars, guiding orbits, weaving invisible threads that keep galaxies whole. In Andromeda, gravity's patience becomes visible. Every star, every cluster, every drifting cloud of gas obeys its rhythm. And yet, within that calm balance there is constant motion. Every second, stars are born and stars die. In dense clouds of gas and dust, gravity gathers material until pressure and temperature rise high enough for nuclear fusion to begin. Light ignites. A new sun is born. Elsewhere in the quiet outskirts, old stars fade, shedding layers into space, creating nebulae that will one day feed new generations. Occasionally, a massive star ends its life in a supernova, an instant of brilliance so powerful that it can outshine the rest of the galaxy for a moment. The shock waves from those explosions compress nearby gas, triggering new star formation. In this way, destruction becomes creation. Andromeda, like all galaxies, is both cradle and grave, both past and future. It is a system in perpetual renewal, a balance of endings and beginnings spread across billions of years. If you could zoom in to a single spiral arm, you would see clouds of gas larger than entire star systems, immense molecular structures where light struggles to escape. Inside those clouds, gravity's slow pull causes fragments to collapse. Temperatures climb, densities rise, and eventually stars flicker to life. Around them, disks of dust form planets. Some remain bare and rocky. Others grow oceans or clouds. We can only imagine what kinds of skies might exist there under Andromeda's distant suns. To imagine such a world is to feel the scale differently, not in numbers, but in experience. A night sky there would glow with countless stars brighter and denser than ours. Its own Milky Way would appear as a dim oval smudge, a mirror of the view we see from Earth. Somewhere, someone could be looking up at that blur, wondering what it is. The thought creates a bridge across light years, not a literal one, but a bridge of curiosity, a shared act of looking outward. Andromeda is not just large in measure. It is large in meaning. It embodies how vastness can also be quiet, how enormity can still feel intimate. When we gaze at it, we participate in an exchange that has lasted for millions of years. The light left, and we receive it. We become part of its journey. If you trace that journey backward, you find not just a galaxy, but a story of expansion itself. The space between Andromeda and us is not fixed. It stretches as the universe expands. Yet Andromeda is close enough and massive enough that gravity overcomes that expansion. It is falling toward us, drawn by a shared center of mass somewhere between our galaxies. In roughly 4 billion years, they will meet. Picture that future slowly and gently. At first, the two galaxies will overlap visually, their spiral arms crossing. Gravity will distort them, pulling long streams of stars into arcs of light. Gas clouds will collide, compressing and triggering waves of new star formation, vast fields of blue suns flaring into being. The cores will pass through each other, separate, and then fall back together again. Over billions of years, the pair will merge into one, a new elliptical galaxy with a bright central heart and long tails of stars fading into the dark. From the surface of whatever worlds exist, then the night sky will bloom with light, an ocean of stars stretching from horizon to horizon. But for now, the motion is so slow that to us, the galaxies remain still. Their approach is a whisper, not a rush. The same calm pattern that defines Andromeda's scale also defines its future endless patience. Andromeda's immensity also reshapes our sense of home. Our solar system, our planet, our lives, all of it fits into a fraction of its structure. If the Milky Way were reduced to the size of a single cup, Andromeda would be 2 cups placed side by side. The space between them on that scale would be only a few steps apart. Yet each cup would hold hundreds of billions of stars, planets, and histories. Even smaller still is our own world, a single grain of dust orbiting one star among many. And yet, that grain is capable of thought, capable of wonder. That may be the most profound scale of all that consciousness, fragile and fleeting, can hold galaxies in mind. So the next time you glance upward, remember that what you see as a faint smudge is a structure of impossible size suspended across time. The photons you catch are older than our species, older than the shapes of the continents, older than everything human. They traveled 2.5 million years to arrive not one less, not one more. They crossed empty space that might seem lifeless, yet even that emptiness is part of the story, a medium through which the universe shares its light. And if you let that thought rest quietly, something changes inside you. The galaxy no longer feels far away. It feels connected, woven through the same cosmic fabric that binds everything. You breathe, and in your breath are atoms that once drifted between stars. You blink, and in that blink light from another world meets your sight. Even as you lie there now, the Milky Way and Andromeda approach each other. Their orbits shift imperceptibly, their halos touch faintly in the dark. The motion is slow, but it is happening. The universe moves without sound, but never without meaning, and in that motion lies the truth of scale, that size and time are not limits, but invitations. They remind us that existence unfolds at many rhythms: the quick beat of a heart, the turning of a planet, the orbit of a star, the slow dance of galaxies. Andromeda's scale is not a boundary. It is a continuum. It is a way of saying you are part of something vast, but also something continuous, something whole. Let that thought drift with you now. The galaxy remains above, serene, immense, ancient, a silent light on the edge of perception, yet large enough to hold 1 trillion suns. And you here are part of that same creation made from the same dust resting under the same sky. And so we drift onward still beneath the soft arc of Andromeda's light. The mind, half awake, half dreaming, continues its quiet orbit around wonder. The galaxy remains vast and still turning with the grace of a thought that never ends. To look upon it is to feel both ancient and new, a witness to time that began long before our kind, yet somehow waiting for our eyes to arrive. The story of Andromeda is not only a story of stars and light, it is also a story of names, of myths, of minds trying to make sense of what they saw above them. Before there were telescopes. Before science gave the sky its modern language, people looked upward and saw meaning in the dark. They drew lines between stars and called them constellations, not because those patterns truly existed, but because the human spirit needed stories to live among the stars. Andromeda. The constellation became one such story, a thread of mythology woven into the heavens. In Greek legend, she was a princess, the daughter of King Cepheus and Queen Cassiopeia, who boasted of her beauty and angered the gods. As punishment, Andromeda was chained to a rock by the sea, offered as sacrifice to a great creature Cetus. But before the monster could reach her, she was saved by Perseus, the hero who had slain Medusa. Freed and grateful, she became his bride, and together they were placed among the stars. It is strange and beautiful that this ancient myth now gives its name to something far greater than any kingdom or sea. The princess of legend became a galaxy of 1 trillion suns. Her story, once told around fires and temples, now drifts through the universe in the language of light years and spectra. But even with all our knowledge, the poetry remains. Science did not erase the myth. It expanded it. It gave the myth a body, a shape that glows across 2.5 million years of space. Long before the Greeks, Persian, and Arabic astronomers recorded the same blur of light. In the 10th century, the Persian astronomer Abd al-Rahman al-Sufi described it in his Book of Fixed Stars as a small cloud. He drew it carefully on parchment near the figure we now call Andromeda. To him it was neither divine nor symbolic. It was an observation, a thing seen and noted, its beauty left for others to find. Even then, humanity had begun to turn myth into measurement, the first steps from wonder toward science. For hundreds of years, though, Andromeda remained a mystery. When telescopes were invented in the 17th century, they revealed the faint mist more clearly, showing it was not a single point of light like a star, but an extended swirl. Astronomers began to catalog such objects, calling them nebulae, Latin for clouds. There were many: the Orion Nebula, the Crab Nebula, the Sombrero, and among them the Andromeda Nebula. At the time, no one knew what these clouds truly were. Some thought they were clusters of stars within our own galaxy. Others believed they might be something else entirely, perhaps other universes. The debate lasted for centuries. The 18th century brought clearer instruments and sharper images. Charles Messier, a French astronomer, was searching for comets, those brief glowing travelers of the solar system. But he kept finding faint fuzzy patches that were not comets at all. To avoid confusion, he created a list of these objects, the Messier Catalog. Andromeda became entry number 31, Messier 31. He described it as a bright, elongated nebula with no visible stars. In that act of cataloging, Andromeda entered the scientific imagination, labeled not as a myth, but as a mystery to be solved. Time drifted forward. Telescopes grew larger. Astronomers began to wonder, could these nebulae be island universes? As the philosopher Immanuel Kant once suggested, separate realms of stars, floating in the same cosmic sea as our own. For a while, this idea competed with the belief that the Milky Way contained all the stars there were. To settle the question, astronomers needed distance, not in poetry, but in measurement. They needed to know how far away Andromeda really was. That answer arrived in the 1920s through the work of Edwin Hubble. Using the 100-inch Hooker telescope on Mount Wilson in California, Hubble studied Andromeda in detail. He found something remarkable: tiny points of light within the galaxy that flickered rhythmically. These were Cepheid variable stars, a kind of star whose brightness rises and falls in a predictable pattern. The longer their period of variation, the brighter they truly are. By comparing their intrinsic brightness to how dim they appear from Earth, astronomers can determine their distance. Hubble's calculations showed that the Andromeda Nebula was far outside the Milky Way, about 2.5 million light-years away. The conclusion was clear and astonishing. Andromeda was not a cloud within our galaxy. It was another galaxy altogether. The universe, it turned out, was vastly larger than anyone had imagined. In a single moment of insight, humanity's understanding expanded from one galaxy to billions. The sky itself became infinite in scope. That discovery changed more than astronomy. It changed perspective. For thousands of years, people had looked at the heavens and seen them as a dome around Earth, a stage upon which light played. Now the stage became endless. The Milky Way was no longer the whole universe, but one of countless islands drifting through a cosmic ocean. Andromeda was the first of those islands to be recognized, the first to teach us that our home was not alone. There is something profoundly human in that moment, the way curiosity transformed myth into measurement, and measurement into meaning. The tools changed, the language changed, but the impulse remained the same to look upward and ask, what is that Hubble's discovery was not a rejection of wonder. It was wonder refined, rendered in the language of numbers and light. Even now, nearly a century later, that same spirit continues. Modern telescopes orbiting far above Earth's atmosphere have mapped Andromeda in exquisite detail. They reveal thousands of star clusters, regions of star birth and death, intricate patterns of dust and gas. The Hubble Space Telescope, named in honor of Edwin Hubble, captured an image known as the panchromatic panorama of Andromeda, a mosaic of more than 400 individual exposures. It is the largest and sharpest image ever taken of a galaxy. Every pixel represents a star, every star a potential world. The scale is so vast that it defies comprehension. And yet within that precision there is still poetry, because every pixel of that image is light that traveled across 2.5 million years to reach the telescope's sensors. It began its journey when ice sheets still covered much of Earth, when the ancestors of humans had just begun to shape tools from stone. The image is both scientific data and a time capsule, a portrait painted in photons older than our history. To think about that is to feel the continuity between myth and science. Both arise from the same need to connect with what lies beyond us. In myth, Andromeda was chained to a rock caught between danger and rescue. In science, the galaxy that bears her name is caught between gravity and expansion, bound to us by attraction drifting toward eventual union. Both stories describe tension, transformation, and release. Both are human attempts to find meaning in vastness. It is comforting to remember that science did not replace mythology, it grew from it. The earliest observers, Persian, Babylonian, Greek, were not wrong to see the sky as full of story. They were naming relationships, tracing the connections they felt between heaven and earth. Their myths were ways of understanding pattern, motion, and change. And when science arrived, it continued that work with new instruments and new questions. The telescope replaced the story's voice, but the intent was the same: to listen more closely to the sky. Now, centuries later, we still do this, but with radio waves, infrared sensors, spectrographs, and satellites. We measure wavelengths instead of omens. We chart light instead of legend. But the sense of wonder remains unchanged. It's still the same quiet awe that once made people draw constellations and tell stories by firelight. Perhaps that is the real continuity that across all time humans have always needed the sky to remind them of perspective. To remind them that we are small, but capable of reaching far. That even in a universe of unimaginable size, meaning can be found in a single faint glow above the horizon. Andromeda, through both myth and science, holds that reminder perfectly. It is both the princess in chains and the galaxy in motion. Both ancient story and modern revelation. It is the place where imagination meets observation, where wonder becomes knowledge without losing its gentleness. Tonight, as you listen, you are part of that same lineage. You are another observer, separated by centuries from those first astronomers, but united in curiosity. You are using the oldest human instrument, attention, to touch something 2.5 million years away. Let that awareness settle like starlight in your mind. The night is the same night they saw. The stars are the same stars. And the faint glow of Andromeda, the same mist that once inspired myth and later defined science, still waits patiently above, unchanged and eternal, visible to any quiet pair of eyes willing to look. You are looking at the same light that once puzzled philosophers, inspired poets, and guided astronomers to the edge of understanding. You are part of that story now. And that too is a kind of myth, one that continues softly each time someone looks up and wonders what they are seeing. Andromeda's tale reminds us that progress in understanding does not replace mystery. It deepens it. The more we know about its stars, its structure, its history, the more questions arise about how galaxies form, why they merge, how dark matter shapes their fate, and what lies beyond even them. Each discovery opens into more not knowing, like a door leading into another corridor of quiet questions. Science, like myth, is an infinite conversation, and the sky, like the mind, has room for both. So, as you rest here now, remember this. Every generation looks at Andromeda differently, but each sees the same light. From a princess in legend to a spiral of stars from a cloud in the Persian sky, to a photograph captured by orbiting telescopes, the transformation is immense, yet seamless. The human gaze remains the constant thread. Let that thread carry you further softly into the next chapter of this story, where Andromeda is not alone, but part of a greater family of galaxies. A cluster of neighbors drifting together through cosmic night. The story continues quietly. Andromeda remains before us, vast, luminous, and endlessly turning. Its myth has softened into knowledge, but its wonder remains whole. Now the light we've followed begins to reveal its company, the other galaxies that share its silent neighborhood in the deep dark of space. For even galaxies do not drift alone. They gather in families drawn together by gravity's patient hand. The local group, that is the name astronomers give to our small cluster of galaxies bound by mutual attraction across several million light-years. It is not large, not by cosmic standards. Beyond it lie greater clusters and sprawling superclusters, Virgo Coma Laniakea, immense gatherings of hundreds, sometimes thousands of galaxies. But here in our small corner of the universe, the local group is home. At its heart dwell two giants, the Milky Way and Andromeda. They are the anchors of this quiet gathering, the two great spirals whose gravity shapes the motions of everything nearby. Between them, space stretches like a tranquil sea, thin dark, filled with only a few drifting galaxies, faint dwarf companions, and the unseen threads of dark matter that connect them all. Andromeda sits about 2.5 million light-years from us, its halo already brushing against our own. Though the gulf between them is vast, the two galaxies are not drifting apart as most do. They are moving toward one another, drawn by their shared gravity into a long, slow embrace. The local group contains roughly 50 galaxies, though galaxy can mean many things. Some are enormous spirals with sweeping arms like Andromeda and the Milky Way. Others are small and irregular faint clouds of a few billion stars, or fewer barely held together by their own gravity. Many orbit around the giants like moons caught in their gravitational wells. Around Andromeda alone, astronomers have found at least 30 such companions, dim spheroidal galaxies, some barely visible even in deep exposures. They are remnants of a cosmic past, survivors of collisions, fragments of what once were. Two of them, M32 and M110, are easy to see in small telescopes. They appear as faint ellipses near Andromeda's shining disk, quiet satellites accompanying their great host. Both are dwarf elliptical galaxies stripped of gas and dust, their stars old and red. Over billions of years, Andromeda's gravity has pulled at them, drawing out streams of stars that now arc around the galaxy in delicate threads. These stellar streams are the footprints of past interactions, ghostly trails left behind when smaller galaxies are torn apart and absorbed. In this way, galaxies grow. They are not static structures, but living systems shaped by encounters and mergers. Each one carries within it the memories of the galaxies it has consumed. Andromeda's halo, the vast sphere of faint stars surrounding its bright disk, holds the remains of dozens of smaller systems, their stars scattered but not forgotten. The Milky Way bears similar scars. The Sagittarius dwarf galaxy, now stretched into a ribbon of stars encircling our sky, is one of many that have been subsumed. Through these quiet absorptions, galaxies evolve not violently, but slowly with the patience of eternity. The local group's shape is a subtle one, not a sphere, but an elongated cluster stretching roughly 10 million light-years across. Its center of gravity lies somewhere between Andromeda and the Milky Way, as if the two were partners in an ancient dance. Around them revolve smaller companions, the Triangulum Galaxy, or M33, third in size, the large and small Magellanic Cloud satellites of the Milky Way, and countless faint dwarfs discovered only recently through deep surveys. Triangulum, though modest beside its neighbors, is beautiful in its own right. A spiral galaxy about 60,000 light-years across, it is thought to be gravitationally linked to Andromeda, perhaps orbiting it, perhaps passing near it in long, slow loops. Triangulum's blue arms shimmer with young stars and nebulae regions of active creation that contrast with Andromeda's more settled maturity. In some ways, it acts as a bridge between the two giants, the younger sibling in a family of light. If one could step outside the Milky Way and look back upon this cluster, the sight would be serene. Two vast spirals facing one another across the dark, their halos touching faintly. Around them, small galaxies glimmer like scattered jewels suspended in near emptiness. The distances between them are immense, yet gravity binds them all unseen but unbreakable. Each galaxy moves in quiet arcs, its path determined by the collective gravity of the group. This motion is not random. It is a slow choreography written into the fabric of space. Within the local group, gravity's influence dominates over the universe's expansion. On larger scales, galaxies drift apart as space itself stretches. But here, the mutual pull of the Milky Way and Andromeda holds the region together. Their combined mass, including the invisible halos of dark matter surrounding each, outweighs all their smaller companions by far. Together, they form a kind of double star system on a galactic scale. Each orbits their shared center of mass, moving gradually toward collision. It's easy to think of collision as chaos, but cosmic collisions are acts of creation. When Andromeda and the Milky Way finally meet 4 billion years from now, the event will not be catastrophic in the way human minds imagine. The stars themselves are too far apart to collide directly. Instead, their mutual gravity will draw long streams of stars into new patterns. Gas clouds will compress, igniting bursts of star formation. Both galaxies will stretch and twist, then merge, forming a single larger structure, a new elliptical galaxy glowing softly at the heart of a changed sky. For any being alive, then, the night would be extraordinary. The sky would no longer hold a single band of the Milky Way, but a vast tangle of light, overlapping spirals, arcs of stars. New constellations forming from the slow blending of two galaxies. Over billions of years, the motions would settle, the turbulence easing until the two became one. Their stars mixed, their black holes merged, their histories intertwined. That future galaxy will carry both names, both legacies, merged as completely as the light of sunrise. This slow destiny reminds us that even on the largest scales, change is constant. No structure in the universe is eternal. Galaxies grow, merge, transform, and fade. Clusters themselves will one day disperse as expansion continues. But for now, the local group endures a small, peaceful gathering, drifting together through an infinite sea. Within it, every galaxy is both solitary and connected. Each moves through its orbit with quiet dignity, influenced by the mass of its neighbors, but following its own path. Between them lies a medium so thin that a cubic meter might contain only a few atoms, yet through that emptiness, gravity's thread still holds. It is a reminder that connection does not require closeness, only attraction, balance, and time. Dark matter plays the unseen role in this cosmic community. Though invisible, it outweighs the visible matter of stars and gas by a factor of 5. Its gravity sculpts the framework within which galaxies form. Without it, neither Andromeda nor the Milky Way could exist as they do. The halos of dark matter surrounding both galaxies extend far beyond their visible disks, overlapping like translucent spheres. In that overlap, their future merger is already written. Dark matter, though unseen, ensures the dance continues. Imagine floating outside this entire group at some vantage point far above. Below, you would see islands of light Andromeda, bright and elongated, the Milky Way a dim, dusty spiral. Triangulum smaller but distinct. Between them, hundreds of faint dwarfs sparkle faintly. And beyond them, stretching into the black, the gravitational influence fades. Past that border, galaxies drift away, drawn toward larger clusters, toward the immense structures that thread the universe like a web. The local group itself is part of a larger entity, the Virgo supercluster, which in turn belongs to an even greater flow called Laniakea, a Hawaiian word meaning immeasurable heaven. Through this hierarchy, the pattern repeats galaxies grouped into clusters, clusters into superclusters, superclusters into filaments that span billions of light years. And yet, no matter how large the scale becomes, the relationships remain the same systems bound by gravity, held in a vast but delicate equilibrium. In this cosmic web, the local group is a small, quiet eddy, a calm region where the great tides of expansion are subdued. Here, galaxies move in slow spirals, their orbits shaped by ancient gravity. It is a place of balance, of proximity, of patient motion. From Earth, this neighborhood feels vast, but from the universe's point of view, it is intimate. Within just a few million light years, 50 galaxies share existence, each luminous with its own story. In a universe containing hundreds of billions of galaxies, the local group is a small family huddled together against the immensity of space. Andromeda, at its heart, is the eldest sister of that family. Her light dominates the sky of any who look her way. Her gravity anchors the group's structure. She pulls faint companions into orbit, shapes their motions, and guides the slow dance that will one day bring her and our own galaxy together. In her vast stillness, she holds both past and future, the record of what has been and the promise of what is to come. Perhaps that is why looking at Andromeda feels strangely personal. It is not just another object in space. It is our neighbor, our eventual partner, our reflection in the cosmic mirror. Through it, we glimpse our own galaxy's future, a slow merging, a transformation written in the quiet laws of motion. And as you rest beneath this idea, let the image expand in your mind. Picture the Milky Way and Andromeda as two luminous spirals floating in the black, slowly curving toward one another. Between them, the local group drifts a cluster of light in the deep sea of dark energy. Their motion is soundless, unhurried, yet sure, a choreography unfolding over eons. And though we measure it in numbers and trajectories, it is also a kind of story, a poem written in the geometry of gravity still unfolding. Even now, in this moment, as you breathe quietly, their approach continues. The space between them narrows by a fraction of a light year every few centuries. It is too slow for any eye to see, too vast for any clock to mark. But it happens all the same. The same patience that built the stars continues its work quietly, steadily, without pause. Andromeda in the local group is not only a fact of astronomy. It is a meditation on connection. Every galaxy, every star, every atom is part of an invisible web moving together through time. We are not outside it. We are inside it, participants in its unfolding, made of the same matter, drawn by the same laws. We belong to this group not by proximity, but by origin. The hydrogen that fills Andromeda's arms is the same hydrogen that once filled the early universe, the same that flows in the stars of our own Milky Way, the same that burns in the sun and lives briefly in you. Let that thought settle the unity of it, the calm continuity. The local group drifts onward. Andromeda glows. The Milky Way turns. All around, faint galaxies shimmer like dew on an invisible web. And though time will reshape them, the pattern will endure, quiet, balanced, endless. You can rest within that thought. The cosmos, vast beyond measure, is still a single connected whole. And somewhere in that gentle expanse, Andromeda moves through the night, steady, luminous, eternal. The night continues to unfold around us, still and deep. The Milky Way turns slowly overhead, a pale ribbon of light, the home of our own star, our small world. And somewhere beyond the Andromeda Galaxy glides through its quiet orbit, vast and deliberate. For a moment, imagine both together, two spirals adrift in the same cosmic sea. In the last chapter, we lingered among their neighbors, the soft cluster of galaxies that form our local group. Now we draw closer to the two great anchors of that group, the Milky Way and Andromeda. They face one another across 2.5 million light-years of space, their halos already brushing faintly together. They are companions, not rivals. Their differences are subtle, like variations between two voices singing the same song. Both are spiral galaxies, grand wheels of stars and dust turning slowly through time. But the Milky Way carries a bar of stars across its core, a bright elongated bridge of light that feeds gas toward the center. Andromeda does not. Its structure is smoother, its spiral arms broader, its shape more symmetrical, a graceful swirl of light without the cross of a central bar. Where the Milky Way seems to move with energy and restlessness, Andromeda drifts with steadiness and calm. Our galaxy spans about 100,000 to 120,000 light-years from edge to edge. Andromeda's disk is nearly twice as wide, stretching some 220,000 light-years. It is larger, heavier, and older, a grander spiral glowing in the dark like a lantern seen from across an ocean. Inside it are roughly 1 trillion stars, perhaps more than twice as many as shine within our own galaxy. The Milky Way holds about 400 billion, a smaller, but still immense population. At the heart of each lies a black hole, a point of gravity so strong that not even light can escape. Ours, known as Sagittarius A, is quiet and modest in cosmic terms, with a mass about 4 million times that of the Sun. Andromeda's central black hole is far more massive, about 100 million suns compressed into a single invisible center. Around each black hole, stars whirl in rapid orbits, tracing invisible paths in the glow of the galactic core. The Milky Way and Andromeda also differ in their pace of creation. Our galaxy is still vibrant with star formation. Its spiral arms sparkle with clouds of gas and nebulae, where new suns are born, glowing regions like the Orion Nebula and the Eagle Nebula, where hydrogen gathers, collapses, and ignites into light. Andromeda, though still forming stars, does so more slowly. Its energy is quieter now, its light warmer and older. It has entered a slower rhythm, less a song of beginnings, more a steady hum of endurance. Each galaxy is surrounded by companions, small satellites that drift in their gravitational fields. The Milky Way is attended by more than 50 known dwarf galaxies, including the large and small Magellanic Clouds that shimmer faintly in the southern sky. Andromeda holds fewer, around 30, perhaps more yet unseen among them. M32 and M110, small elliptical galaxies orbiting close to their giant host. Their stars are older, their shapes round and soft, the remnants of smaller systems drawn into Andromeda's orbit long ago. When you set aside numbers and think instead in imagery, the two galaxies resemble twin spirals of different moods. The Milky Way glows with youthful vigor, bright arms alive with new stars, restless and full of movement. Andromeda shines with a quieter golden light, broader, slower, older, yet still magnificent. They are like two seasons of the same being, one in midlife, one in maturity, both beautiful, both necessary. If we could see them together from afar, they would appear as two whorls of silver drifting in black space, their halos nearly touching. Their rotations are immense, each star completing its orbit around the core in hundreds of millions of years. Each revolution brings the two galaxies infinitesimally closer. Gravity draws them together gently, unceasingly. And someday, 4 billion years from now, the two will meet. It will not be a violent collision, as the word might suggest, but a long, slow blending. Their stars will not crash. They will pass through one another like ghosts. Gravity will pull long arcs of light between them, streams of stars stretched into ribbons. Gas clouds will collide, compress, and ignite new waves of star birth, a brief renewal before calm returns. Over time, their shapes will change. Spirals will unravel their arms, fusing into a single luminous mass. At the center, their black holes will circle each other, merging eventually into one. The result will be a new galaxy, a vast elliptical form, sometimes called Milky Way. It will shine for trillions of years before slowly fading into starlight's twilight. Yet that future is not a story of destruction. It is a story of transformation. Stars will continue their orbits unharmed, though their constellations will change. New worlds will form from the debris of old. The night sky of that distant future will glow with double the stars, a tapestry of light so rich it would seem almost alive. For now, though, both galaxies remain separate, suspended in their patient approach. Their shared gravity is a thread stretched across millions of light years, invisible but sure. We cannot feel it yet. It binds us the same force that keeps our feet to the ground, that holds the moon in orbit, that shapes the path of every star. Astronomers sometimes speak of the Milky Way as a younger, more restless system, full of creation and movement. Andromeda, larger and calmer, has seen more of cosmic time, its light mellowed, its pace slowed. The comparison is not of competition, but of harmony. Two expressions of the same cosmic pattern, two variations of the same universal design. Around both halos of old stars extend far beyond their bright disks. These halos are like the faded edges of memory remnants of galaxies long ago absorbed their stars, now circling as faint ghosts. Andromeda's halo, broader and more complex, bears the signatures of ancient mergers. Delicate streams of light arcing across hundreds of thousands of light years. Evidence of smaller systems, consumed in its long evolution. The Milky Way shows the same though subtler traces of dwarf galaxies, stretched and scattered over eons. In both history is written not in words, but in orbits. The two galaxies were born of the same cosmic substance. Both arose from clouds of hydrogen and helium in the early universe, shaped by gravity into spinning disks of stars. Their elements, carbon, oxygen, iron, and all the others, were forged in earlier generations of stars and spread through space by supernovae. They share the same ancestry, the same chemistry, the same dust that makes worlds and living things. In every way that matters, they are kin. When you look at Andromeda on a clear night, you are not just looking at a neighboring galaxy. You are looking at your own reflection stretched across time and space. The light that touches your eyes began its journey before human beings existed, before language, before history. and yet it arrives here now, meeting a mind capable of wondering where it came from. In that meeting, the two galaxies are no longer distant. They are joined by gravity, by origin, by perception. To compare them, then, is not to divide them. It is to recognize a unity too vast for comprehension. Two galaxies bound by the same laws, shaped by the same forces, moving toward the same destiny. Their paths remind us that nothing in the universe is truly solitary. Everything is connected by light, by matter, by time. And so, as you rest now in the dark, remember that the faint blur above you, that oval of ancient light, is not a stranger. It is a sibling, a mirror, a fellow traveler through the same endless night. Our galaxy and Andromeda turn together in the quiet current of the cosmos, slowly, gracefully toward a future written not in haste, but in harmony. Even across millions of light years, their connection endures. And within that truth lies something deeply human, that everything in existence, no matter how vast or distant, shares one rhythm, the rhythm of becoming, of changing, of belonging. Let that rhythm move through you softly now, like the turning of galaxies, the Milky Way, bright with youth. Andromeda, wide with age. Two halves of one unfolding story, both drifting through eternity together. You are still adrift in quiet thought, following the slow dance of galaxies through the dark. The Milky Way turns behind you, Andromeda ahead, their light spread across millions of years. They seem eternal, motionless, steady, vast beyond measure. And yet we know they move. We know how far they are, how fast they travel, how deep their halos extend into the night. We know these things not because we have touched them, but because we have learned to listen to light. Measuring a galaxy is an act of patience, a long conversation with the faintest glimmers of energy that reach our eyes. Every distance, every motion, every hidden truth begins as light. That is all we have ever received from Andromeda light that began its journey before there were humans to see it. And somehow within that light, the universe has encoded its own story. The question is simple. How far away is Andromeda? But the answer requires subtlety. A ladder of methods, each one resting on another, each one built from centuries of observation. At the heart of this work lies a rhythm, the heartbeat of certain stars. In the early 20th century, a woman named Henrietta Swan Leavitt studied variable stars in the Magellanic Clouds, small galaxies orbiting our Milky Way. She noticed that some of them brightened and dimmed with steady regularity. The brighter the star, the longer its cycle. This discovery, the period-luminosity relationship, gave astronomy a new kind of ruler. Such stars, called Cepheid variables, could reveal their true brightness by the tempo of their pulse. By comparing their intrinsic brightness to how faint they appear, one can calculate distance. When Edwin Hubble turned his telescope toward Andromeda and found Cepheid variables within it, the result was astonishing. Their brightness was far too low for them to belong to the Milky Way. They lay millions of light years away, proving that Andromeda was another galaxy, not a nearby nebula. That realization expanded the universe overnight. In that moment, the faint smudge of light became a cosmos in its own right. Since then, astronomers have refined the measure again and again. Cepheid variables remain among our most reliable beacons, but they are only the first step of what is now called the cosmic distance ladder. Each rung builds upon the previous, extending reach and precision. Closer to home parallax, the slight shift of a star's position as Earth moves around the Sun provides exact distances for nearby stars. Those stars in turn calibrate the Cepheids. Beyond them, other tools appear: Type Ia supernovae planetary nebulae, the red giant branch. Each type of light serves as a known candle in the dark, a reference for distances ever greater. And yet all these measures rely on a single assumption that the laws of physics are the same everywhere. That light behaves in Andromeda as it does in our own skies. That gravity bends space there just as it does here. So far, the universe agrees. To measure motion, astronomers turn to the colors of light. Every star and galaxy emits a spectrum, a rainbow of wavelengths shaped by the elements within it. When an object moves away, its light stretches sliding toward red. When it moves closer, it compresses shifting toward blue. This is the Doppler effect, the same principle that makes a siren's pitch change as it passes by. Most galaxies in the universe show redshift, meaning they are receding from us as space expands. But Andromeda's light is blue-shifted. Its waves are slightly compressed, revealing that it is moving toward the Milky Way at about 110 kilometers per second. This motion, invisible to our eyes, is the signature of their slow approach. Every second, the distance between us narrows by that small fraction of a kilometer, too little to feel too sure to stop. Spectroscopy, the study of light's composition, reveals more than motion. It uncovers chemistry, temperature, and the hidden presence of dust and gas. By splitting Andromeda's light into its spectral lines, astronomers can read the fingerprints of its elements: hydrogen, helium, oxygen, nitrogen, iron, the same elements found here on Earth. These lines show how fast the stars move, how the galaxy rotates, and even how dark matter shapes its outer disk. The technique is simple in principle, but immense in power. A spectrograph collects light and spreads it into a pattern of colors. Tiny dark lines appear where specific wavelengths are absorbed by atoms in the star's atmospheres. From the spacing and tilt of these lines, scientists measure velocity, distance, and structure, all from light alone. It is a kind of remote touch, a way of tracing form from across eternity. When astronomers mapped Andromeda's rotation, they discovered something unexpected. Stars in its outer regions orbit the center at nearly the same speed as those nearer the core. If only visible matter were present, the outer stars should move more slowly. The fact that they do not suggests an unseen mass, something that exerts gravity without shining. This is how we came to understand dark matter, the invisible substance that makes up most of Andromeda's weight and indeed most of the universe's. To imagine dark matter is to imagine structure without surface. It does not glow or absorb, but it shapes. It surrounds Andromeda in a vast spherical halo extending far beyond the visible galaxy, perhaps 1,000,000 light-years in diameter. Without it, the stars would drift apart. With it, they remain bound, moving in perfect, silent arcs through the dark. Light tells us more still. In radio wavelengths, Andromeda reveals immense clouds of hydrogen gas. These clouds extend beyond the visible arms, forming the raw material for new stars. Infrared images show regions of dust warmed by starlight glowing gently in heat. Ultraviolet images highlight clusters of young hot stars blazing in the upper reaches of the spiral arms. Each wavelength tells a different story, a different layer of the galaxy's being. Together they form a portrait that no single form of light could reveal. The tools we use to gather this light have changed over time, but their purpose remains constant. The early telescopes of glass and metal gave way to giant mirrors on mountaintops, and then to observatories floating above the atmosphere, the Hubble Space Telescope, the James Webb, and others. Each extends our sight a little farther, gathers a little more of the faint light that has traveled so long to reach us. Every image is a gift of patience, photons captured after millions of years turned into knowledge and wonder in the space of a moment. Sometimes the act of measurement feels almost tender. To study Andromeda is to listen for whispers across an unimaginable gulf, to trace meaning from the faintest gleam. Each observation is a question sent into the dark, and each photon that returns carries an answer. Through those answers, we learn not only about the galaxy, but about ourselves, about our capacity to perceive, to wonder, to reach outward with minds made of the very elements we study. Even the smallest refinements matter. The precision of distance, the accuracy of motion, each tells us something about the larger rhythm of the universe. When Hubble first measured Andromeda's distance, he overestimated slightly, not yet knowing the full complexity of Cepheid stars. Later, astronomers corrected it, placing the galaxy at 2.537 million light-years away. Now, using data from the Gaia spacecraft and other observatories, we can measure its distance to within a few percent. Every adjustment brings us closer to truth, but also closer to humility, the recognition that knowledge itself is an ongoing voyage. In the quiet mathematics of these measurements lies something poetic. Light distance, velocity. They are the grammar of the cosmos. Each observation is a word in the universe's long sentence. Each new technique refines our translation. And yet, even when the numbers align perfectly, a deeper mystery remains. Why is there something rather than nothing? Why does light behave in this elegant way, carrying across time the signature of its source? Science does not replace wonder. It clarifies it. Andromeda, as measured, is not diminished. It becomes more profound. Knowing its distance does not make it nearer, but it does make its presence more intimate. It becomes a real place, not just a blur of light, a disk of stars, a core of fire, a halo of dark matter, a future partner in our cosmic dance. Measurement turns imagination into belonging. The act of measurement itself is an ancient echo of myth. Early astronomers used sextants, charts, and naked eyes. Modern ones use satellites, spectroscopy, and computer models. But both are guided by the same impulse to know where we stand in the vastness. To measure the heavens is not to master them, it is to be in conversation with them. To say softly, "We see you, we are here too." Through each refinement, the picture grows clearer. Andromeda's mass is now estimated at about 1.5 trillion times the mass of the Sun. Its rotation speed at the edge of its visible disk is roughly 250 kilometers per second. Its halo extends beyond 1,000,000 light-years. Its central region glows with old stars. Its arms spiral with younger ones, and between them lies the dust and gas of creation still ongoing. These are not just facts. They are forms of awe given structure. If you close your eyes and imagine all this, the light, the motion, the hidden mass, you may sense the scale of the achievement. Human eyes, human minds, reading the structure of galaxies from nothing but light. A fragile species on a small planet measuring the cosmos with the faintest of tools. It is almost beyond belief. And yet, it is true. Each time we observe Andromeda, we repeat that miracle. We gather photons that began their journey long before we existed. We turn them into numbers, patterns, and understanding. And in doing so, we close a loop the universe perceiving itself through us. There is a quiet beauty in that. Science in its truest form is reverence made methodical. It is not the opposite of poetry. It is its continuation in another language. The instruments hum, the data flows, the numbers align, and beneath it all is the same stillness you feel now listening to the stars. The light of Andromeda continues its travel tonight, unchanged by our measurement, unhurried by our gaze. It drifts across space, photon by photon, until some small fraction finds our telescopes, our eyes, our hearts. Each one is a messenger from an ancient sun carrying its story in silence. And so the measuring continues, as it always will, patient, gentle, infinite. For every answer opens a new question, and every question keeps us awake within the dream of the universe. We do not measure to possess, but to understand. We measure because the act itself connects us to the light, to the stars, to one another. The galaxies remain vast and still while we small and transient reach upward. And somewhere between the two, knowledge becomes peace. The journey continues gently. You are still drifting in thought, still floating between the galaxies. Behind you, the Milky Way glows like a river of light. Ahead, Andromeda turns in silence, its arms unfurling like luminous ribbons in the dark. You've followed its story through light and distance, through ancient myths and patient measurements. Now, let yourself rest within its shape. Every galaxy holds a pattern. Andromeda's is a spiral, the most graceful of cosmic forms. It appears simple at first glance, a bright center, two great arms winding outward through space. But nothing about it is fixed or rigid. Its spirals are not solid structures, not permanent trails of stars frozen in place. They are waves, vast ripples of density moving through the galactic disk, shepherding stars and gas in their wake. The shape you see is a moment in motion, like the crest of an ocean wave that is never the same twice. If you could watch Andromeda unfold across millions of years, you would see those arms breathe. They tighten and loosen their patterns, drifting slowly as stars move through them. New stars form within the arms and drift outward, aging as they go until they fade into the thin spaces between. The spiral pattern remains, but the stars themselves do not stay. The galaxy is both solid and fluid structure and flow. It turns not like a wheel, but like a storm, ordered yet alive. At its center lies a glowing heart, a golden core packed with billions of old stars. From afar, it looks like a soft point of light, but up close it is a crowded city of suns. Each star orbits the core at immense speed, their combined motion creating the illusion of stillness. The light from this region is warm, leaning toward yellow and amber, the color of age. Here, star formation has mostly ceased. The gas has been consumed or scattered, leaving behind the quiet luminosity of long-lived suns. Surrounding this heart, the spiral arms begin their sweep outward, pale blue in young regions, dusted with pink nebulae where new stars ignite. These colors are not decoration. They are language. Blue marks the presence of massive hot stars, short-lived, brilliant, fierce in their light. Pink glows from ionized hydrogen gas, lit by ultraviolet radiation from those same young stars. Together, they trace the paths of birth, showing where gravity is gathering clouds into life. Andromeda's arms are wider and more extended than those of the Milky Way. From the core, they sweep outward in grand arcs, curving for hundreds of thousands of light years. Within them, rivers of dust flow like shadowed filaments, breaking the light into soft gradients. These dark lanes are made of the same material that builds planets: carbon silicates, iron, fine grains, drifting in space, cold and ancient. To human eyes, they appear as soft veils laid across the starlight. But to the galaxy, they are the seeds of creation reservoirs from which new generations of stars will form. The structure of these arms is maintained by gravity and motion. As stars and gas orbit, the center's slight variations in density move through the disk, compressing gas as they pass. This compression triggers star formation, which lights the arms, making them visible. But the stars move onward, leaving the pattern behind. The spiral itself remains not as an object, but as a rhythm. It is a slow rhythm older than mountains, older than life. A single rotation of Andromeda's disk takes about 240 million years. By the time the galaxy completes one turn, the continents on Earth will have shifted, the constellations will have changed, and the traces of our civilization may have faded. And yet, the spiral will continue turning endlessly in the dark, patient and beautiful. This slow rotation is not uniform. Stars near the center move quickly, circling in tens of millions of years, while those farther out take much longer. But because the entire disk is bound by gravity, the pattern of the spiral persists. Astronomers call this a density wave. It is the music of galaxies, invisible constant shaping everything we see. If you could stand within Andromeda, the view would be extraordinary. From a world within one of its outer arms, the night sky would blaze with stars hundreds of thousands visible to the naked eye, some so close they would cast shadows. The nearby arms would stretch across the heavens like glowing rivers, bright clusters strung along their curves. The core would appear as a distant golden glow brighter than any star. To see such a sky would be to live inside light itself, and yet even their change would be constant. Stars form, shine, and die. Massive ones burn through their fuel in a few million years, ending their lives in supernova, titanic explosions that scatter elements into space. Those elements, carbon, oxygen, iron, drift through the galaxy, merging with clouds of gas, forming new stars, new worlds. The spiral is not merely a shape, it is a cycle of transformation. It is the universe learning how to create and recreate itself. Within Andromeda's spiral, astronomers have discovered smaller galaxies, companions caught and absorbed over time. Two of them, known as M32 and M110, are still visible nearby, but many others have been devoured completely. Their stars now orbit within Andromeda's halo, forming faint tidal streams that arc around the galaxy. These streams are the fossilized traces of long-ago mergers, cosmic rivers of memory flowing around the main disk. They show that Andromeda's beauty is not static. It is the result of countless interactions, collisions, and transformations spread over billions of years. The Milky Way carries similar scars, and in this way the two galaxies reflect each other again. Every spiral pattern we see is the outcome of ancient motions, galaxies colliding, merging, reshaping themselves through time. The spiral is both memory and future, the record of what has happened, and the blueprint for what will come. As instruments grow more sensitive, we see more of Andromeda's structure than ever before. The Hubble Space Telescope revealed star clusters, dust lanes, and nebulae in exquisite detail. Infrared images show its cooler regions, where stars have aged and dust glows faintly in heat. Ultraviolet observations reveal bursts of young blue stars at the edges of its arms. Radio telescopes trace hydrogen gas far beyond the visible disk, showing that the galaxy extends far into the darkness. What we once thought of as a single shape is now known to be a complex ecosystem, alive, layered, changing. But even with all this knowledge, the spiral still feels mysterious. Its symmetry, its persistence, its quiet grace, all seem to hint at a deeper order. Perhaps it is because the spiral is a universal form. We find it everywhere in shells, in storms, in the pattern of a seed's growth. It appears in galaxies, and in the smallest living things, a recurring gesture of nature. It seems to describe how energy flows, how matter organizes itself, how the universe breathes. Andromeda's spiral is not separate from that pattern. It is part of the same design, the same tendency toward balance, the same rhythm of motion and rest. Each arm carries the memory of rotation, each cluster the promise of renewal. When we see that pattern from Earth, we are witnessing something that transcends scale, a form that repeats from the smallest to the largest structures, from the curl of a wave to the turn of a galaxy. If you trace the arms inward, you eventually return to the golden core, where light becomes dense and smooth. At the very center lies a point of absolute gravity, the supermassive black hole that anchors the galaxy. Around it, stars race at immense speeds, their light bending in gravitational arcs. Though invisible, the black hole defines the galaxy's center of balance. It is the still point around which all motion turns a void that gives the spiral its form. Without darkness, there could be no pattern of light. Beyond the arms in the outer reaches of Andromeda's disk, stars thin out and darkness deepens. The spiral fades into the halo, a realm of old stars and invisible matter. Here, motion slows and light dims, but the gravitational field still holds everything together. This is where the visible galaxy ends, and the invisible one begins the boundary between what we can see and what we can only infer. The more you learn about Andromeda's spiral, the more it becomes a metaphor for existence itself. It is both dynamic and tranquil, both fleeting and eternal. Each turn of its arms is a record of billions of years, yet it moves in silence. It holds chaos and order in the same shape. It reminds us that beauty does not require perfection, only motion, balance, and time. Imagine now the two galaxies, Andromeda and the Milky Way. Both spirals, both turning, both alive in the same rhythm. From afar, they look like reflections of one another, two luminous storms moving through the dark. Each has its own music, but their harmonies overlap. Eventually, their spirals will intertwine, forming one vast pattern, a merging of forms into something new. In that future, the arms will stretch and blend, the waves of density will merge, and the light of both galaxies will flow together. Even then, the spiral will not vanish. It will evolve, reshaping itself into a new expression of the same eternal motion. The universe does not keep still. Everything from the smallest atom to the largest galaxy moves. And within that movement, patterns arise, spirals, rings, filaments, orbits. These patterns are not random. They are the ways the cosmos finds harmony within change. Andromeda's spiral is one such harmony, a long, slow turning that reveals how gravity can sculpt beauty from emptiness. So when you look at Andromeda, perhaps through a telescope, perhaps only in your imagination, you are not just seeing light. You are seeing movement slowed to stillness. You are seeing a wave frozen in time. You are seeing the trace of a rhythm too vast to hear. In its spiral lies the truth that all things turn stars around galaxies, planets around stars, hearts within bodies, thoughts within minds. Everything moves, and in that motion, everything connects. Let that thought settle softly within you. The galaxy continues to spin, calm and endless. Its arms drift outward, its core glows steadily. Its halo breathes around it like a luminous tide. And somewhere within that great spiral of light and time, the seeds of new stars are gathering again, quiet sparks waiting for their moment to ignite. The spiral continues to turn even as you breathe. Andromeda drifts through the dark, her arms unfolding in slow, endless grace. She is quiet, yet never still. And as her stars move through their invisible patterns, something of that motion echoes within us. For we too are made of the same material that glows within her, the same hydrogen, the same carbon, the same dust. We are not merely observers of her light. We are participants in her story. Each time you look upward, whether through a telescope or through thought, you become part of that connection, a bridge between the galaxy's ancient fire and your own small flame of awareness. You may feel small beside her, but the truth is subtler. Your perception of her is proof that the universe, at least in part, has become conscious of itself. Andromeda shines, and you see her. Light meets mind, and something vast becomes intimate. When we speak of Andromeda's size or age, the numbers are immense trillions of stars, billions of years. But within those scales, meaning unfolds. The atoms that make up your body were once part of such stars. They burned, they died, they scattered. Over time, those scattered fragments gathered again, eventually forming the elements that now allow you to think, to listen, to dream. To contemplate Andromeda is to look into the mirror of your own origin. Every breath you take is part of a cosmic exchange. Oxygen forged in a star long ago. Hydrogen born in the universe's first moments. When you exhale, you release those same atoms back into the air, where they may someday drift into another body, another world, another sun. You are not separate from the galaxies. You are their continuation condensed into consciousness. Andromeda's light left her 2.5 million years ago. It crossed intergalactic space, the near emptiness between galaxies, to arrive at Earth, where it now rests softly upon our nights. In those 2.5 million years, entire species have come and gone. Ice ages have risen and faded. Forests have grown burned and grown again. Civilizations have appeared, flourished, and changed, yet the light kept coming patient and constant. To see it now is to witness a gesture of cosmic endurance, a wave of energy stretched across time, still reaching you without hurry. There is something humbling in that realization. It invites stillness, the way standing before the ocean does. You understand that your life, brief and small in scale, is still a necessary part of this vast system. One note in an endless symphony. The spiral does not exist without its smallest stars. The universe is not complete without you. In Andromeda, we find not only astronomy, but philosophy. She teaches patience, for her arms take hundreds of millions of years to turn. She teaches humility, for even her grandeur will one day dissolve when galaxies merge and fade. And she teaches continuity, for nothing that disappears is truly lost, only changed, only carried forward into new forms. If you look at the night sky and feel small, remember the same chemistry, the same starlight that fills those galaxies flows within you. Your eyes are the eyes through which the cosmos sees itself. Your thoughts are ripples of matter organized into awareness. When you observe Andromeda, you close the circle between creation and comprehension, a connection that transcends distance and time. The philosopher Carl Sagan once said, "We are a way for the cosmos to know itself." That is not a metaphor. It is a physical truth. The universe has evolved stars that can think, galaxies that can dream through us. We do not stand apart from it, gazing from the outside. We are embedded within it, built from its dust, moved by its gravity, lit by its light. This awareness transforms observation into meditation. Andromeda becomes not an object to study, but a presence to sit beside. You might imagine her as a vast, luminous being, not alive in our sense, yet full of rhythm, memory, and transformation. Her arms, turning through the dark, are like the breath of the universe itself, inhaling, exhaling, creating. To contemplate her is to slow down, to align your inner motion with hers, to feel the calm of her rotation settle into your own pulse. In the quiet of that alignment, the boundaries between here and there begin to dissolve. You are not watching her from afar. You are moving with her. Your planet, your solar system, your entire galaxy is part of the same gravitational dance. The Milky Way and Andromeda are already connected, already moving toward each other through invisible threads of force. The space between them is not empty. It is alive with the tension of their mutual pull, a slow approach that will last billions of years. To rest within that awareness is to feel yourself held within something larger, something vast and unbroken. Sometimes when people gaze at Andromeda, they speak of insignificance. They see her magnitude and feel reduced. But insignificance is a misunderstanding of scale. The galaxies are large, yes, but they do not lessen you. They contextualize you. They show that existence can hold both enormity and intimacy. That vastness is not absence, but presence spread thin. The immensity of Andromeda does not make you small. It makes you infinite by association. You are part of what she is. Human history, in contrast to Andromeda's age, is a flicker, a brief shimmer of thought on a cosmic timeline. And yet, that shimmer is not meaningless. It is the spark of curiosity, the same curiosity that led ancient people to name her, that led Hubble to measure her distance, that leads you to listen now. We are temporary forms of a long, ongoing question. The universe asks itself, "What am I?" And through us, it begins to answer. Andromeda, seen from Earth, is an emblem of that inquiry. Her faint glow, visible to the naked eye, connects past and present the eyes of shepherds, philosophers, scientists, and dreamers, all looking at the same light. Each generation interprets her differently, yet all feel the same quiet pull toward understanding. She is continuity embodied, the unbroken thread of attention stretching through time. Perhaps that is why she soothes. Her stillness reminds us that the universe is not chaotic but balanced. Her age reminds us that impermanence can also be endurance. And her beauty reminds us that complexity and calm can coexist, that even in the swirling chaos of motion there is elegance. If you listen to her long enough, Andromeda teaches a deeper lesson still, that nothing truly ends. Stars die, but their elements become new stars. Galaxies merge, but their light continues. Matter dissolves into energy, and energy condenses into matter again. The universe does not vanish. It transforms. And in transformation, it renews itself. The same is true for us. Our lives, short as they are, participate in the same pattern. We too are born, burn brightly for a time, and then return our elements to the larger whole. In this sense, Andromeda is not only a distant galaxy. She is the shape of our own, becoming the pattern of life, death, and renewal written in the language of stars. This awareness can bring peace. To know that your atoms have journeyed through stars, that they will continue their journey long after you are gone, is to feel a kind of immortality. You do not end. You change. You drift, you merge. You become part of something else, the same way galaxies do. From that perspective, even sleep begins to feel cosmic. Each night when you close your eyes, you drift into a state not unlike space itself. Dark, quiet, infinite. The mind expands, the boundaries blur, and in that stillness, you return to the same rhythm that governs galaxies. You become part of the same calm that turns Andromeda's arms. If you could translate her motion into sound, it would not be music as we know it. It would be a tone so low, so slow, that it would stretch across ages. A single chord resonating through space-time, steady and endless. When you breathe deeply and slowly, your rhythm begins to match hers. The heart beats, the lungs expand and release. The mind settles all in time with the greater turning. That is what Andromeda offers us: perspective without distance, serenity without stillness. She shows that the universe is not somewhere out there. It is here within us, moving as we move, resting as we rest. The same laws that guide her spirals guide our atoms. The same balance that holds her stars holds our thoughts. And so, when you look toward her, whether through your window or within your mind, let her be both a fact and a meditation. She is science and stillness, knowledge and grace. She is proof that beauty and order can arise from chaos, that light can travel for millions of years and still find a home in your eyes. And as you rest beneath that knowledge, let a simple truth settle over you. Like starlight, you are made of the same matter as the galaxies. You are not beneath them. You are part of their unfolding, their becoming, their quiet glow. Even as you drift toward sleep, Andromeda continues to turn. The Milky Way continues to breathe. Stars are born, fade, and scatter. New stars gather, light begins again. Everything flows, nothing stops. And through it all, the pattern remains calm, endless, luminous. You have traveled far tonight. Across light years of distance and millions of years of time. From the small patch of sky above you, your thoughts have wandered into the quiet arms of Andromeda. Through her golden core, her spiraling light, her ancient rhythm. Now it is time to return not downward, but inward. Back to the stillness where all of this began. The night outside remains calm. Perhaps the room is dark or dim with the faint shimmer of a clock or a candle. Perhaps the only sound is the slow pulse of your own breath, and somewhere beyond the walls, beyond the clouds, beyond even the air itself, Andromeda glows faint and constant, her light still arriving as it has for ages. That light is older than any human story. It began its journey before our species existed, before words were spoken, before the oceans took their present shape. And yet, after all that time, it found you here, in this single moment, in this single breath. It does not matter that the galaxy is vast and you are small. In truth, you are made of her. The atoms that flicker within your body were forged in stars, not unlike those that fill her spiral arms. You are not looking at something distant. You are looking at your own past, your own origin shining back across the dark. Imagine yourself now beneath that sky, perhaps lying on soft grass, perhaps floating through thought. The air is cool, the world is still. Above you, the constellations drift slowly west, and near the faint outline of Andromeda's constellation, a small blur of light glows barely visible, yet unmistakable once you find it. It looks like nothing more than a breath upon glass, and yet it holds 1 trillion stars. The longer you look, the softer your gaze becomes. Your breathing slows, matching the slow turn of the earth. Andromeda remains there serene, patient, almost shy in her brightness. You feel no need to think, no need to measure. You simply are. And so is she. 2 forms of the same matter resting quietly in the same universe. In your mind's eye, you might picture the galaxy as she truly is immense beyond comprehension, but not chaotic. Her arms curl outward in luminous grace, blue and pink and gold. The outer stars glide through the dark like lanterns on a river. The inner ones circle in golden fire. Everywhere motion continues, yet nothing feels hurried. It is a serenity born of scale so vast that even movement becomes stillness. Within that stillness, your thoughts soften further. The day's concerns drift away small as dust motes in the glow of her light. There is nothing left to do, nowhere else to go. The same calm that fills Andromeda now fills you. Slowly, the edges of awareness blur, not lost, but dissolving into something greater. A shared quiet between you and the night. You remember perhaps that Andromeda is moving toward us, that in 4 billion years she and the Milky Way will merge, forming a new galaxy. But even that future feels gentle now. The galaxies do not collide in violence. They meet in grace. Their stars drift through one another unharmed, their lights blending in silence. Even creation, it seems, can happen without haste. That same grace moves through you. Every heartbeat, every breath, every thought is its echo. The universe expands. Stars are born and die. Galaxies drift and merge, and you are part of that rhythm. Your body, your mind, your sleep are made of the same calm motion. When you rest, the universe rests in you. Let your breath become slower still. Let your body grow heavy against the bed, against the earth that carries you. The gravity that holds you here is the same gravity that shapes galaxies, the same unseen force that keeps Andromeda turning. It does not hurry. It does not fail. It simply holds. In that holding, you can let go. The universe will continue its quiet work. The stars will go on shining. Andromeda's light will still cross the void long after this moment fades. You do not need to follow it anymore. You are already part of it. Imagine her one last time, a swirl of light in the dark, a galaxy turning endlessly. Now imagine yourself as one point of that same spiral, small radiant, perfectly placed. Everything in you belongs. Everything in you is at rest. The night deepens. The galaxies turn. The universe breathes. And you too breathe with its slow, quiet infinite. If you are still awake, let your mind drift a little farther, perhaps to another sky, another story. If you are already slipping into sleep, let the cosmos hold you. You are safe within its rhythm, within its silence, within its endless light. The same atoms that shine in stars breathe within you. The same gravity that binds galaxies keeps you close to this earth. The same darkness that cradles Andromeda now surrounds you in calm. The universe continues vast, patient, serene. You can rest now. You can sleep. And somewhere above you, a trillion suns shine softly on.